All right. So it's now time to solve with actual code some actual problems, albeit in a fun and visual and audio way. But recall that where we left off was this. Like starting next week, you'll be writing code that ultimately looks like this. But thankfully, you will not be writing zeros and ones. And no normal person, myself included, can understand what all of these zeros and ones are at a glance. We could take out some paper pencil and probably figure it out very tediously. But this is exactly the point. Computers only understand this stuff. But what we as programmers will start writing today and beyond is code at a higher level. And indeed, this is going to be frequent within computer science, where there's different levels of abstraction that we operate at. And the lowest level, the nittiest gritty, is like the zeros and ones that computer understand. That's it in this class for zeros and ones. Hopefully, you at least have wrapped your mind around why zeros and ones can be used in triples and as bytes to represent higher and higher numbers. But let's just now agree that computers can do that. Let's abstract away from that detail and focus on higher level languages than zeros and ones, namely a language like this. So this is an example of the very first programming language I learned back in the day, as per that homework, in a language called C. It's an older language, but it remains one of the most popular languages and omnipresent languages nowadays because it's incredibly fast and it's particularly good at making devices operate quickly. For us pedagogically, the value of C is not that you're probably in Silicon Valley and other such jobs going to be using C yourself that much, but because it's going to provide a conceptual foundation on top of which we introduce other languages like Python, which is newer and improved, so to speak, that gives you more and more functionality sort of for free out of the box by abstracting away some of the stuff we'll focus on in the coming days first. So at the end of the day, you should better understand languages like Python and JavaScript and SQL because of your underlying understanding of a language like C. But this is too much for the first day. Many of you will think that this is too much for the second week. But in fact, C is really only sort of scary looking because all of this darn punctuation and syntax, the semicolon, the parentheses, the double quotes, the curly braces, and the like. And I concur. This is intellectually uninteresting. And a lot of the challenges early on when learning programming is you just don't have the muscle memory like that I or some of the teaching fellows might for knowing what symbols should be where. But that's going to come with time and practice. I guarantee it. What we'll do for today, though, is just throw away all of that intellectually uninteresting detail and focus really on ideas. And some of you might be in your comfort zone here, because if back in middle school you were playing with a programming language called Scratch, you were probably using at the time just to have fun in class or out of class, making games, animations, interactive art. What you probably didn't use it for, at least in middle school, was to consider and explore programming languages themselves. But what's wonderful about Scratch, which is this graphical programming language from down the street at MIT, where it was invented some years ago, is you can program not by using your keyboard per se, but by dragging and dropping puzzle pieces, otherwise known as blocks, that will snap together if it makes logical sense to do so. And what you won't have to deal with is parentheses and double quotes and semicolons and all of that, at least until next week. But the nice thing about Scratch is that after this week and after the so-called problem set 0, the first assignment in which you'll use Scratch, you'll have a mental model via which it will be easier to pick up all of the subsequent syntax as well. So let's see how we can start programming in Scratch by making the simplest of programs first. You can do this at scratch.mit.edu. You needn't do this now in the moment. Problem set 0 will walk you through all of these steps. But what I've done here is opened up at scratch.mit.edu, precisely the default web page therein. This is after having clicked the Create button in Scratch, which is going to allow me to create my first program. But first, a tour of the user interface here and what is ultimately available to you. Well, within the Scratch environment, we'll see a few different regions of the screen. One, we have this palette of puzzle pieces at left. The blue ones relate to motion. The purple ones relate to looks. The pink ones relate to sound and so forth. So the color of the blocks just roughly categorizes what that block's purpose in life is. We're going to be able to use those puzzle pieces by dragging and dropping them from left to right. In the right here, in the middle of the screen, is where I'm going to write my actual programs. This is where I'll drag and drop these puzzle pieces, lock them together, and actually write my code. What am I going to be coding? Well, I'm going to be controlling one or more sprites. Much like in the world of games, if familiar, a sprite is like a character that you might see on the screen. The default character in the world of Scratch is, in fact, a cat that looks like this. And if, in this case, I have just one cat, I can then make that cat do things in his own little world at top right by making the cat move up, down, left, right, spinning around, or doing other things as well. But if you want to introduce a dog or a bird or any number of other custom characters, you just add more sprites, and they get their own place in that same world. As for how to think about movement in this world, it's actually pretty familiar, even though it gets a little numeric for a moment. If Scratch at the moment is in the middle of the screen, the cat is at 0, 0. If you think about x, y coordinates or latitude, longitude, if you move the cat all the way up, this would still be x equals 0, but it would be y 180. What's the 180? 180 pixels vertically, or dots on the screen. This is negative 180 pixels on the screen at the bottom. By contrast, if you go left and right, your x value might change, negative 240, but y is 0, or positive 240, and y is 0 as well. But most of the time, you won't need to know or care about what the pixel coordinates of the cat are. All you're generally going to care about as the programmer, most likely, is do you want the cat to go relatively up, down, left, or right? And let MIT figure out the mathematics of moving this thing around in most cases. All right, so let's go ahead and introduce the first of these programs by doing something quite simple, as we did in C there, but a little more simply by writing code as follows. I'm going to go back to scratch.mit.edu. I've already clicked, per before, the Create button. And if I click on the yellow category of blocks here at left, and I'll zoom in, we'll see a whole bunch of yellow puzzle pieces. And probably the most common one you will use to write code in Scratch for just this first week is literally when green flag clicked. Why? Well, if we go back over to the cat's world at top right, notice that above the cat's rectangular world, there's not only a green flag for starting, there's a red stop sign for stopping as well. So let's do this. Let me go ahead